Hello, welcome to your tutors AM. In this video, we're going to be looking at the differentiation rules, but particularly we're going to be looking at some implicit rules, the quotient rule, and some trigonometrical differentiation and basic differentiation of certain numbers or natural logs of things. So let's say we have been given such so this is basically quoting the quotient rule, but let's say we have been told to find dy dx of things of x squared plus 1 over 3x minus 2. So let's say we want to find something like this. So the basic thing that we have to know is that we have to pick which one will be our u. So as for me, my u is the top part and then my v is the bottom part, so we just have to replace. So in form of replacing, in case I do not want to write dy of dx, you can also represent this as f prime of x. You can represent this as f prime of x and say this is equal to, now we can differentiate this. So once we differentiate what we have as u, notice that we have 2x. So when we differentiate u, we're going to have 2x. So I'm going to say 2x, and then when we differentiate this, we're just going to have, we're not going to differentiate this, sorry, we're just going to write that as it is. So when we're done with this part, now we're just going to do the reverse of that. I'm going to differentiate 3x minus 2, which is just going to be 3, and then I'm going to write the basic this one and differentiate it as it is given, x squared plus 1, and then all this will be over my v squared, which is 3x minus 2 squared. So now we can go ahead and simplify that. So we're going to say this. So there, once we multiply, we're going to have 6x squared, that times that's minus 4x, 3 times that, we're going to have minus 3x squared minus 3, and then all this is over 3x minus 2. So once we simplify what we have on the top part, we're going to get 3x minus 4 minus 3, so we're going to have 3x squared minus 4x minus 3 of 3, and then this is all going to be over that is 3x minus 2. So then this has been f prime of x. So if you wanted, you can go ahead and use the power rule and differentiated this further. Yeah, that's if that's if you wanted, but I suggest leaving this the way that it is. Yeah, now let's go to the implicit rule. So the implicit rule is very simple, and in fact I doubt if it's a rule as much. It's just something that you need to know. It's basic math, I should say. So let's say you have dy of dx being equal to something. So how can you write another form of representing dy dx? How can you represent that? So if I wanted, I can say dy, sorry, let me just write my dy properly, I can simply say dy of, let's say, dt of my dt times dt over dx. Notice that these are the same. The dt and the dt will just simply cancel each other out. That's just something I thought we should go over. So that's basically it about the implicit function. As at this level that I'm at, implicit functions and talked about plenty of times. So now let's look at the derivatives of trigonometrical ratios. So the derivative of sine, we're going to have d of sine over dx. We're going to have d of sine over dx is equal, let me say d of sine x of sine x. This is basically going to be equal to cos x. And then d cos x over dx is equal to minus sine x. And then now we're going to have d tan x, because you know that tan is sine over cos. So once you use the quotient rule, you can find that the derivative of tan is sec squared of x. So these are the basic derivatives of the basic trigonometrical ratios, sine, cos, and tan. So these are the basic derivatives. So just in case you are given in a question, it's very handy to know those, especially for pure mathematics. I'm sure such a question can arise. Yeah. So now let's look at the derivative. So let's say we have been given d of over dx. I'm not really sure how to explain this one, but the derivative of that is basically the same. They once asked me this in a certain test, and I used the product rule and said x e minus 1, then basically did something way off, but that is how we represent that one. And then another way of representing this is another way of representing, it should be the product, or when we have an exponent. Let's say we have an exponent, two exponents multiplying each other over dx. What do you think would arise from such? Notice that our ax, that my a, I'm just going to get my a, and then that will multiply my e, and then I'm going to have ax. Yeah, so that's basically what I thought I should share my thoughts on. So this has been your tutor ZM. Please subscribe to the channel, share with friends, like the videos, and I'll be seeing you guys in the next video.